Video with my P8 students. We're going to be discussing the last part of Unit 1 in terms of the units for the AP test. All right, and this is going to be about the normal distribution. So if you're thinking about our text and the work that we did this class for this material, it would be from Chapter 6. Chapter 6 from our textbook, our units, in terms of if you want to check out any notes you did previously. So let's look at number 1. They give us two normal models, two normal curves. All right, so I'm just going to draw real quick. This looks to be the middle. So 6 is my mu for that one. So let's do this. So mu and sigma. So this one is 6. And then what do you think the middle is for this other one? 18. I agree. 18? I agree, 18. So 18. All right. Now, do you guys remember when you do a normal model, a normal curve, how many standard deviations I carry going above and below? 3. Very good. So if we try to count, right, to get to the end of this curve, I know it goes on forever, but like to the end of this curve, right, if I did a standard deviation of 1, I would be 6, 7, 8, 9. Do I finish like almost all my data at 9? No. So let's, instead of doing a standard deviation of 1, let's bump it up. Let's go to 2. So 6, then the next one would be 8, then 10, and then 12. Do I get to pretty much all of my data with 12? I do. So what is my sigma or standard deviation for this one? It's 2. Now doing that same process for the curve labeled B, what's going to be my standard deviation for that one? Benjamin, you're right. It is 1 standard deviation. I started with 1. I tried to do 1 starting at 6, so 6, then 7, 8, and 9 to get to 3 standard deviations above, but that wasn't enough to get it. So if I change my standard deviation to 2, then here's 1 standard deviation, 2, and then 3. Okay? All right, so let's answer the question. All right, which one has the larger mean? Which one has the larger mean? B, so larger mean A, no. And which one has the larger standard deviation? A. So is it C? Yes. So the key reminder for that one was, do you remember about the 3 standard deviations above and below? That's what we care about for the normal model. All right, here we go. Let's do some calculations in our calculator. So we have a trucking firm determines that its fleet of trucks averages a mean of 12.4 miles per gallon with a standard deviation of 1.2 miles per gallon. Now notice in the instructions, it says for 2 through 7, assume these distributions are normal. So the moment I read that, I'm going to use that capital letter N for normal model, and I've got my mu and my sigma. So in this case, the mu is 12.4 mpg, and my standard deviation is 1.2 miles per gallon. It says, what is the probability that one of the trucks averages fewer than 10 miles per gallon? So this is a question of, I'm going to find a z-score, right? I'm going to standardize that number of 10, and then use my calculator, draw my sketch of my normal model to find the area under the curve. All right, so first off, do you guys remember the formula? No. It's a normal model, right? We said these are normal. Then the bottom is sigma. The bottom is the standard deviation. What's in the top? The mu is not going to be minus. It's going to be minus mu. Do you remember what letter I put in front? I use letter Y, but you can also use what letter? X is fine as well. All right, I don't care. All right, so the 10 replaces letter Y, and the mu and the sigma, so 12.4 is my mean, and the sigma is 1.2. Guys, if you don't remember how to do this, right, it is going to be on the AP exam, so make sure you're getting a chance to read that Barron's review book. All right, go to your calculator. We're doing 10 minus 12.4 divided by 1.2 to get negative 2 is my z-score. Now, do you guys remember what that means when a data value has a z-score of negative 2? No. Let me see if this will help. All right, so here's my curve, right?
Oh, it's shades towards the left.
We're going to get there, yeah. What's right down the middle? The mean, which was 12.4, right? And here's 10. Okay. What's the z-score for the mean? No, what's the z-score for the mean? It's 0. Nice, Alonzo. And what's our z-score for 10? -2. So what I'm trying to say is that the data value 10, if a truck averages 10 miles per gallon, it is 2 standard deviations below the average truck. Okay? So in some instances, like in some contexts in the world, right, you would like to be a z-score that's positive, right? Z-score that's negative, depending on what the context is, right? I have children that are starting to come through the education system, right? My oldest child's in 1st grade. So when he gets his scores back for these, STAR testing, all these tests that he does in his school, I always get to see his percentile, which is just another way of saying his z-score. So on those ones, I'm hoping he's a z-score that's really, really far towards 3, right, in terms of his intelligence. Does that make sense? All right. So you guys have gotten that, I'm sure, with your SAT score as well, like your percentiles. All right. So let's shade. You said shading, Mia. Do you know which way we should shade for this problem? How do you know it's to the left? Not because it's negative. It is to the left, Mia. You're right. But it's not because it's -2. All right. Just ignore them. It's the best way to deal with it. Anyone know? Why is it to the left? What word in the problem is telling us to the fewer? Fewer, right? It says fewer. If it said more than, which way am I shading? To the right. So just make sure you're ready for those words. So fewer is shading. Well, I just shaded to the right. To the left. Sorry about that. Got all excited. I know. Hashtag goofy. Where's Raul when you need him? All right. It's a P7 joke. No worries. All right, so go to the calculator. All right, you ready? Ready, Mia? Hit it. Second vars. All right, do you guys remember which one to pick? Not inverse. We actually have the z-score. We're trying to find the area. So it's actually normal CDF number 2. Number 2 is what you want to choose. Normal CDF. Okay, what is my lower bound? No, my lower bound, if I'm shading to the left. Excellent. Negative infinity. And then what's my upper bound? No, that would just give you 1, right? No, we standardized it. We standardized 10, -2. All right, so the answer is approximately 0.023. So this right here is 0.023. How would you, it doesn't say percentage, but if it said a percentage, what would that be as a percentage? Approximately 2.3%. But if you look at letter B, that is our answer. Any questions on number 2? I know it's been a long time since we've done this, guys. A long time. Since September. Let's do number 3, and then we will be done for today. Number 3. A factory dumps an average of 2.43 tons of pollutants into a river every week. If the standard deviation is 0.88 tons, what is the probability that in a week more than 3 tons are dumped? So we got a normal model. What is our mean? 2.43 tons. And our standard deviation, 0.88 tons. So this is actually a very similar problem to what we just did. Thank you. We're trying to standardize 3, right? More than 3 tons. So 3 minus 2.43 over sigma of 0.88. As in the problem, it says we're trying to figure out what's the likelihood that in a week more than 3 tons. So if it said more than 5 tons, I would have chosen 5. So 3 minus 2.43 divided by 0.88. Now, what I'm going to do here is I'm going to end up rounding now. I know it goes against what I told you guys in my class in previous lessons and previous videos that you should always wait till the end to round, but I'm not that concerned about it. So technically, if I want to get as close to the right answer as possible, I should copy down all those numbers, 0.6477, 272727 goes on forever, right? So I'm just going to round to 0.648, knowing that technically this is going to give me a wrong answer. All right, so I draw the curve. Where is 0.648 as a z-score? No, because this is a z-score of 0, right? So where is a z-score of 0.648? A little bit to the right. Okay, and be careful which way we're going to shade. Why to the right? Because it says more than. Okay, so let's go to our calculator. I'm going to do second vars, normal CDF. This time, what's our lower bound? 0.648. Again, if you wanted to get more of a right answer, you would put in the 0.64772727. It's okay, not worried about it. Upper bound, infinity. And so this answer is 0.258. So look at your answer choices. I'm going to pick the one that's closest. All right, and the one that's closest is letter A. All right, guys, so that hopefully is a good review. And as I said, I'm going to do 4 through 7 with my other class. So you can watch that video after this. But very similar to what we just did. I would watch it because there's at least one, if not two, that go the other way. Alonzo had mentioned the inverse norm, where I give you the area, and you've got to pull the z-score from that and do some algebra to figure that question out. So definitely worth watching the next video. Good luck.